Hello class, I'm back for the second half of notes here where we now talk about angle bisectors. So an angle bisector is a line that bisects a given angle. A line that bisects a given angle. So if we're looking here, right, thinking side, AD is the angle bisector. So right, if we have this segment here, this line, sorry, and it's bisecting that angle, we're trying to figure out, well, what does that mean about BD and CD? Right, notice those are the distances from the point to our sides. And what we're going to notice, what this theorem tells us, is that those are also, using that new vocab word, equidistant to one another. So right, the angle bisector theorem states if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So right, if this is true, right, if that is bisected, then these segments are also equal to one another. So if we need to pause the video, please feel free to do so. Now we also have our converse of this, right? Just like we did for perpendicular bisector, we have the converse that just states, hey, if we have some point that is equidistant to the two sides, well then it is on the angle bisector of that angle. And it is on the angle bisector of that angle. So we now have the angle bisector theorem and now the angle bisector converse theorem. So we're going to use that to help us answer some questions. So looking at this one, it says, is B on the angle bisector of angle A? Now this is one where we're going to use the converse. We're going to use the converse. So notice what we're looking at is, are these two distances the same? Are they equidistant? Are they the same as one another? Since they are not, the answer to our question is no. Right? B is not on the angle bisector of angle A. Looking at this one here, right, we start with, okay, notice this one, we are told that it is an angle bisector, right? We are shown right here, hey, this angle is bisected. So now we have to use the angle bisector theorem and think, okay, well, what does that mean? Well, that tells us that these segments, those distances from the bisector to the sides are equidistant, meaning we can set them equal to each other and then solve for x. So what we're going to do is subtract 1. X is equal to 6. And notice for this one, all we're asked for is what is x? What is x? So we found it right there. Now again, if you need to pause it, take your time, please do so. Got one more problem here. So we look here, again, notice we are told they are equidistant, so that helps us out. Or that they are angle bisectors, sorry. So that tells us, okay, these need to be equidistant. So what we're going to do is we're going to take 6x plus 3 and set it equal to 4x plus 9. And now it turns into an algebra problem here. We subtract 4x, we subtract 3. We are now left with 2x is equal to 6, or x is equal to 3. X is equal to 3. So that concludes today's lesson on angle bisector and the converse of the angle bisector theorem.